Hello, and welcome to this presentation. I've titled it End-to-end Testing Without the Pain. And there should probably be an automatic in the beginning, so automatic end-to-end testing without the pain. And either you are here because you got lost at the conference, or you have tried out end-to-end testing and felt my pain. And you will recognize a lot of the things which I talk about in this talk. And I will try to give you tools to come away from that pain and find a way to let these automated end-to-end tests work for you rather than against you. Sounds good? Yes. Have you felt my pain? God damn it. Thank you. We should probably start church instead of having talks. So this is my first time at Øredev. This is my first time speaking Øredev. I've held this presentation a couple of times before, and I think this presentation is, just because you guys felt my pain, this presentation is better if you ask questions. If I say stupid things, things you don't understand, things you don't agree with, just raise your hand and give me the question. I'm a mature, grown man. I can say, no, not right now. You will spoil the session for the rest of the crowd. Take it later. And we can do it at the party. But if it's a good question, I want it to come up here. Because if you have that question, I bet 10 people more have the same question. So just ask the questions. Deal? Yes. Thank you. Deal? Damn it. I want this session to be alive. Thanks. Let's go. I want to take you guys on a trip, which I took 5 years ago. I started at a new company. I started with a new project. There was a lot of tech there. There was frameworks, in-house built frameworks, and I was supposed to build a new application with those frameworks. But software is complicated, right? So I need something more simple. I need something more hardware-like to give this analogy or this example. So this is now a bathroom redecoration renovation project, not a software. It's a bathroom. And I can't grasp the entire bathroom. I just need to focus on one thing. So I focus on when you wash your hands. The sink with its basin and all the pipes, the faucet, and maybe some controls for the faucet. And I start building all these these bathroom components. And I, an adult, a mature man, I am trained in software development. I'm trained in tools like test-driven development, and I like it. I like having automated tests, and by tests, I probably mean checks. It's not exploratory testing, it's probably checks. Someone is nodding here. Quick gallop. Forget about that. Who here is a developer? Right. Who here is a tester? All of you said developer and took your hands down. Please don't raise the hand again, because if you develop code and don't test it, then we need to have a talk. Or maybe you should have a talk with those who just raised their hand when they said we're testers. Because if you heard the talk before lunch about, what was it? Room for improvements? Someone was talking about that. The quality delta, I think the word was. If you don't test your own code, the quality delta will be huge. All right, so I write a lot of unit tests for this. Maybe I can assert that if I put water into the basin, the same amount of water will come out of the pipes. If I push the button on the faucet there, water will come out of it. I can do a lot of nitty-gritty tests for this. And then I put it in the hands of my users, or my family, or my friends who come over for my big party where so you don't have parties for your bathroom, right? That's a weird thing. And then this happens. Have you seen this before? Yes, it's a silly image, but it illustrates what I'm trying to say here. Of course, no one is that stupid. Nobody's just a developer and don't test their own code. Nobody's that stupid in software. Day 1, mind you. Maybe day 10. Maybe day 100. Maybe day 1000 of a software project. Regression starts to show its ugly face in this code base. bugs which for functionality which have been working since day one suddenly occur. Have you all felt that? Yes. And then you fix that weird bug due to some regression, and then a month later, the same bug comes up again. And to me, that's embarrassing. To me, that's a sign of me doing a bad job. I don't like that gut feeling. It's a bad feeling, right? So I got to thinking, because this has happened to me, and I started a new software project. It wasn't the bathroom, if you thought that, kind of silly. It was a new software project, and I was the only one working on this product. So there was no testers, there was no other devs, it was just me. And I was going to work with it for some time, at least a year. And I was super scared of this, because I couldn't test all my code all the time for each and every deploy. It's not possible. I needed something else. And I started thinking a lot about my code, because when I learn more stuff about the domain which I'm working in, when I learn more from domain experts, I refactor my code. I get smarter in the domain. I learn new things, and I want to implement that in code, of course. Which means that sometimes I do large breakthroughs. I learn something new. Oh shit, I have to remodel this big part of the software. Or I need to refactor the model, because suddenly I understand the business problem in a whole new way, and my model, my representation of the domain, was wrong. I need to change that. So I could either change my production code, or maybe I need to change my test, or maybe I need to change both, which is kind of scary feeling, because now I can't trust the tests anymore. So who's there to protect me? I was on my own. I also started thinking, what are we testing? What was I testing? Was I testing features which the users care about, or were I testing functions, implementation details? I think I was testing a lot of functions, implementation details, not so many features. I was testing the faucet, not the entire use case. I want to wash my hands. So I wasn't actually testing the behavior which my users care about. Sad. This was 5 years ago. I'm a better man now, I promise. So the answer to the last question, are we really testing our model, or was I? No, I was not. I was just testing code. Have you seen this? Anybody not seen it? All right. So I was talking about checks, unit tests. This is called the pyramid of tests, or the testing pyramid. It is all automated tests. In the foundation of it, you got unit tests. Test on low level, maybe a class, maybe a function, maybe a component, could be anything. And then you have integration tests, testing multiple classes, components together, putting them together, kind of like the GIF, the image in the beginning. And then you have something called end-to-end testing, or UI testing, could be anything. But basically, you put together the entire application and go through the user interface, the same interface the user uses. Often it's a graphical user interface. I work a lot with web, so it's a web browser going to a page. And you have a real database, and you have real endpoints and dependencies. So it's an end-to-end exercise of your application, system-wide test. Okay. And I was just, when I was doing this project, when I started, I was just familiar with unit testing and integration testing, the bottom layers of this pyramid. And I have been trying to work my ways up in it previously, but I got to things like this. Have you seen this kind of shit before? This is Protractor, which is an Angular focused testing framework. Not sure about the words here, but this is an actual output from a project I was working on. I replaced the project name with Kevin, but this is an actual stack trace from a failing end-to-end test with Protractor, and you can't, even if you want to understand it, you cannot, because this is obfuscated, minified code from the dependency. I can't actually find why the test failed. So this is output from a Protractor test, end-to-end test. And I hated it. I felt the pain. Before this, I used Selenium. Have you used Selenium? Yeah, WebDrive, all of you felt the pain. All of you also have used Selenium. I bet it's a great product, so I don't like it. It's gotten better, of course. Okay, so it doesn't work. End-to-end testing is bad, right? That was my opinion before going into this project. It was 5 years ago. Right. First, I need to establish here what is an end-to-end test. I mentioned it's going through the entire application. I go through the interface, yes, and I want to mimic as close to the production environment as possible, using the same kind of database, using the same kind of application server, going through the actual user interface, no shortcuts, as complete as possible. That's an end-to-end test for me. Okay, so now we have that established. Thanks. I was thinking a lot when I was thinking about these the tests, just testing implementations, the checks. Sorry, not the tests. How am I actually designing my software? And as I said, I was training in TDD, test-driven development. Do you know what that is? Maybe I asked. Yes. Okay. So basically, you write a test first before you have any production code, and then you just need to fulfill that test. So you define a spec, a test, and then just fulfill it by writing production code, which make that test go green. Previously it was red, of course, because there was no code for it. How am I designing my software? Well, since I wrote tests that way, I used a lot of bottom-up design for my applications, meaning I started with the lower-level components, maybe a database integration, writing some data access objects or repositories, call them what you want. Working my way up to some kind of service layer, and then to some controllers or an API, and then now to the browser, maybe some React, Angular, cool front-end framework, insert name here. That was my previous approach. But of course, if that's a way to work, you could just reverse that, right? I'm doing that on a low level with my unit tests. I start with specification and just work my way into the implementation. Are there any benefits or drawbacks with these two, top-down or bottom-up? Of course, bottom-up, I could focus on small details and then putting them together at the end. Kind of cool, kind of like building with Legos, right? We like Legos, since we're probably engineers in the room. And I can break down the problem into small pieces and just tick them off one by one. Database, check. Controllers, check. Domain services, check. Good. Validation, check. Benefits with top-down, we'll get to that. Drawbacks with the bottom-up. It takes a hell of a lot of time before you can see something in a user interface, right? It takes a lot of time. You need to build all these Lego bricks, and then you can put them together, and then you start seeing some kind of shape. It takes a lot of time. When is one preferred? I don't know, we'll get to that. What do my users care about then? Do they care about these Lego bricks, or do they care about the finished Lego model? Any thoughts? Come on, I want you guys. This is simple, right? They care about finished products, yes. They don't care about me building little Lego pieces and putting them together. They want to see something. And maybe I should harness that, maybe. And did you hear the ending keynote yesterday, Natasha Bard? You did? She said something about value, right? Yeah. So software is not valuable until it's in the hands of a human being. So I need to speed that up, all right? So I need to write my tests to focus on what my users care about. Maybe I should try a new approach for that. To just focus on the user, what they want, and write the test for that. And do they care about the inside of a black box? No, so I should probably not start with unit testing, right? So just hit me. As I said, I'm a grown person, mature. I was trained in test-driven development, but it took me about 10 years of that to realize, God damn it, you're stupid, write the end-to-end test first. And this solves a lot of problems, a lot of problems. You know, the pain you felt, most of that will be solved by this quick thing. There's a couple of other things, but this is my first tip to you guys. Write it first. Did you hear the session about how great teams get shit done before lunch? Yeah? Do you remember, I wrote it down actually, he talked about QA kickoffs. Yeah, so the team gathers, right? Maybe a whiteboard, they start thinking about a feature. How should we test this feature? Just write the code for it. Just do it. Do his QA kickoffs and write the test. Don't stop at the whiteboard, write the test for it. Does it matter if it passes? No, just write it. Do it with domain experts, maybe. Why not? So this will get all the benefits of TDD. Are you familiar with the great benefits of TDD? Anyone? Yeah? You want to give it a go? Okay. So if I miss someone, you can just fill in the blanks, please. One of them is that if you write the test first, you get a testable piece of code, because it was designed to be testable, because you wrote the test first. So if you write the unit test first, the unit of code which it needs to test will be testable by design. So if you write a high-level end-to-end test first, the system will be testable by design. It's built into that. And why is that a good thing? Well, maybe because I think that if you write end-to-end tests, are you today? Anyone? Some of you? Do you do it before or after production code is written? After? Anyone before? One. You and I. Very nice. So most of you write them. If you write them afterwards. Test after. And then you have an untestable system. It's not built to be testable like this. So you're already working uphill right there. And probably you're out of time, out of budget, everything. And also, you are probably done with the software, right? So why do you need these tests? They're there to protect you from regression. So basically, it's a useless investment, thank you, as well. So one of the best things with TDD is that you get a testable system. And you get a testable system by doing this on a higher level as well. You're also forced to think about state management. That is one of the hardest things with end-to-end testing, state management. How can I put my system under test in a known state, so known that I can execute a scripted test against it and not have it failing half the time, 2/3 of the time, 9 out of 10 times failing. State management, you have to build that from day one. Kind of cool. And I get to work top down instead. I just write a UI test, an end-to-end test. I start with that, and I can just hack the UI to make the test go green, and then work my way down the stack. And as long as that test is green, I can keep working downwards until I hit the database or whatever it is, which is the most low-level part of this feature. This way, these tests or checks become something else than just tests. They become specifications of this application. So you write them first, they become an actual specification of this feature, and that reduces some of the documentation burden, of course, but they actually serve a purpose of telling someone, for example, new to the team, how this application is supposed to work. And since you wrote it before you knew all the implementation details, the test will be free of implementation details. It will just be almost English language in it, or Swedish, depending on which spoken language you code in. And this way we treat these tests as a first-class citizens, not just something done afterwards, right? All right, but why bothering? If I haven't convinced you yet, why bother writing end-to-end tests? They're flaky and stuff like that, right? Well, I think they're pretty good because you can automate regression testing. You can reduce the number of recurring bugs. They are quite blunt as a tool, I know, but you can keep the basic flows of your application green with this type of testing. So that's one thing. They are framework agnostic. Have you ever been in a project where you rewrite from Angular to React to Vue, going from jQuery to serverless to server-side? Have you ever been there, changing stuff? Yes, and you throw away a lot of tests? Yes, you can keep these. I was in a project a couple of years ago. We had an application built, server-side rendered Blazor, so C# stuff, and we went to Vue. Yeah, oh no, it was the other way around. From Vue.js, client-side rendered stuff with an API, rebuilt it in C#, server-side rendered, and we didn't change a single end-to-end test. They were the same, unchanged during this entire rewrite. Can you imagine the gut feeling of that rewrite? Pretty good, right? Yes. And of course they are testing from the user perspective. They use the same interface as the users do. So it's not just a lot of mocks going straight to an API or straight to a class or a function asserting that we do the right thing in there. It's the actual same way which the users are using. That is why you need them, in my opinion. They treat the application as a closed box. You cannot see the inside. You cannot see the implementation details. And that's why you need them. Unless you're working on software which will live for maximum 6 weeks, then you can skip them. But if you know it's going to live more than that, please write some of them. But, Andreas, these tests are fragile. Come on, say it. They are fragile. And you felt the pain. Yes, you raised your hands. Super fragile. But why? I'll answer that soon. But what do you do when they are fragile? I've heard a lot of suggestions to this. You run them again, of course. You have flaky tests, you run them again. And if they go red again, you run them again. I give you maximum 3 times, and the 3rd time you're out, right? So you can run them, say, 3 times. If one of them goes green, then yeah, I guess it's green. It was probably the sun and the moon and the stars not aligning, I'm not sure. What else can you do? Well, Google has done some research on this to isolate flaky tests. You could do that. Try to focus on making that test not so flaky if you have a single test. I don't know. But I think you should go back one step. Analyze why are they flaky. So now I need your input. I want you guys to give me reasons for this type of test to be flaky. Anything. Nothing is stupid. Give me just one reason. Come on. Data? Like state management? Thank you. The product is flaky? That's why we have test, right? To detect flakiness in the product, okay? Asynchronous code in the browser, so you have to wait for stuff, right? You have to wait for stuff which you cannot control. Awesome. Anything else? Slow runners, what's that? Oh, okay. So the actual machines executing the code are slow. I heard a product manager saying once, they're like Raspberry Pis on steroids. Yes, of course, slow runners in your CI/CD builds. Anything else? Performance? Yes. And you're talking in terms of speed, right? Yeah, because these tests execute at an insane level of speed. Compared to me, a human, a mature person, clicking with the mouse and the keyboard, I'm super slow compared to this automation, this level of automation. They're extremely fast, right? Yeah, yeah. I have a couple of more. Infrastructure, we were there, I think. Infrastructure. Animations. Everything should be so pretty and animated and sliding from the side. It takes 300 milliseconds to do the animation, but the script is so much faster executing. So when the click comes, the animations hasn't even started yet. What else? Yeah, the timing due to high speed depends on external systems. We had API calls, somebody said it. We can have mismatch between the tests and the actual application and the test. So if you have a test environment running the application and you execute your test against that, you can have a mismatch in versions here. And of course, they are written after the application, which means they are not run that many times. So if you have written your application, you're done with it, you write these kind of tests, and then you won't exercise them so many times. Very few, actually. And we have things like Yeah, the database, of course, it could be a slow database, accessing the data. We mentioned state management, of course. All of these things can happen. It's a lot of ways for these tests to go wrong, a lot of pain to be felt. So you think it's a bad idea to write this kind of test because you've all experienced this. But then again, go back a couple of steps. If you use TDD here, you'll write this test the first thing you do, and you execute it. It goes red. You will execute it a couple more times at your local dev station, and it will go red for a couple of times. You actually study the error message. Why is it going red? What kind of feedback am I getting from the red test? Is that understandable, or is it like the initial, you remember the stack trace, the protractor stack trace, unreadable shit? And then all of a sudden it starts going green. Maybe you run this test 10 times. Then you start running it on other people's computers in the CI/CD pipeline. Suddenly it has run a couple of 100 times, a couple of 1,000 times. You get to bash out all the reasons for this test to be flaky at an early stage. So you battle harden it. Right, use TDD for them. Pick the right tool. We were talking a little bit about Selenium, which is based on WebDriver. There are a lot of tools for doing this kind of tests. Right now I use Cypress and I use Playwright, which is two tools to write this kind of tests. I like them equally much. They were not equally created, but I use them and they do the job. The thing with them is that they are not using WebDriver in the bottom. They actually spin up their own instance of a browser, which means they have control of the browser, which means that I have control of the browser, which means that I can, for instance, stub or fake external calls. So if I have a web application which contacts an external API, I can just stub that if I want to. Or if I have a single endpoint in my backend, which is responsible for authentication, I can just stub that and say, the front-end application is authenticated. Great, and it starts acting like it. So it gives us exquisite control of the browser, which is good. So pick the right tools for this. Yes, a question. Good question. If I stub, am I really testing end-to-end? No, I'm not, of course. But I do not want to depend on stuff which I cannot control in these tests, because then they will be flaky by that. So if it's something that is totally out of my control, I cannot build a double for it, I need to mock it. This is the last resort. If you cannot control it in any other way, mock it, sub it, do whatever. Just get rid of that possible error source. Did that answer your question? Great, great question. Thank you. Thank you. I owe you a beer or something. Soda, maybe. I don't know. Whatever floats your boat. I'll have a beer. Other things you can do, reduce the size of your tests. I've seen a lot of tests on this level, which is huge. Hundreds of lines of code. Maybe some setup, and then you have a lot of steps going through, and at the end you assert something silly, actually. The Monty Python reference, yes. And we'll take a look at some of the sizing in detail soon. And my last tip, I promise you guys tips. The last real tip here is to use single-purpose selectors. This is a huge pain in the A if you have this kind of tests and you use the wrong type of selectors. And maybe that doesn't tell you anything right now, but it will pretty soon, I promise you. So let's talk about size. It does matter in end-to-end testing. Thank you. So this is a Cypress test. You can probably read it, right? Anybody not able to read it? Okay, I'll explain it to you. It's a test. It can add a product. It says that on the first line. So we use some kind of homegrown method called search for products. So we search for a product called coffee mug. We take the search result of that, assert that it has a length greater than 1, so there should be at least 1 coffee mug, and we click it. It should be a coffee mug, also it should contain the text, awesome coffee mug. Click it. So now we have clicked something in the search result. Maybe we're on a product display page and we have a new function. Click add to product cart. Do that. Maybe clicks a button. I don't know. Does something. And then the next thing we do, we look at the cart items. It should have the length of 1. And it should be the awesome coffee mug. And the last assert is that the cart should contain the text total 79 kroner, which is a expensive coffee mug for someone from Småland like myself. Pretty readable, right? And you know nothing about the implementation details. You don't have a clue. You know nothing if I'm using JSP, if I have a PostgreSQL database, if I'm using server-side rendered view. You have no idea. You can write this the first thing you do before starting implementing stuff. Is it a feasible size test? Is it too large? Is it okay? Somebody? Too large? Hand up. It's okay. Hand up. Wrong. It's too big. I would rather go with something like this. Okay, so now at least it's 2 tests. One of the features here is to just search for products, right? Many of our visitors come to our web shop and they just search for products and then they leave. They don't buy our expensive coffee mugs. So that's a test. We don't want add to cart functionality tests to fail because you cannot search. We want the search test to fail because you cannot search. So we have 2 tests now. The first is just, can I search? Yes, you can. Great. And second test is, can I add it to a product cart? And then we take a shortcut. We go straight to the product page. We go to Sci Visit and just straight to the awesome coffee mug, and then we add it to the cart. So we take a shortcut here, just to be able to test these 2 things, these 2 use cases, call them what you want, in isolation, so we can get a more precise tool. Of course, the previous one, is better than nothing, but if you have the choice to do this instead, do it, please. And sometimes you actually realize when you write one of these tests that, oh my god, I can write this at a lower level. I can go down in the testing pyramid. So this doesn't actually have to be an end-to-end test. Because end-to-end tests have a couple of drawbacks, like speed. They are super slow running compared to unit tests. They are hard to maintain because they're brittle, and we have all felt the pain, yes. But if you can go lower, if you don't need the browser for this, then please do. It's like limbo, you know, the dance contest. How low can you go in the pyramid? Can you do this with the unit test? Please do. That'll be faster, a lot faster. And try to wrap up things like domain-specific terms in functions like I have here, like search for products. This could be a lot of CSS selectors and stuff, making this test totally unreadable. Please use this instead. Yes, a question? Yes. Yep. Because I'm a human, not so mature, not so good. The kind gentleman pointed out that I'm missing to test actual clicking on the product in the search result. And yes, that's a missing test. I couldn't fit more in the slides, I'm sorry. If this was a real product, a real case, a real customer paying me for my knowledge, I would of course have had that test. Thank you for noticing. Great stuff. Right, about selectors. This was my last tip, right? The selectors. What do I mean by selectors? Well, it's basically how do I find the correct elements in the page? So I'm trying to be young and cool, using some memes in my presentation. All of these 6 lines of code do the exact same thing with the exact same button on the exact same page. But 4 of them are shit. 2 of them are, one of them is okay, and one of them is great. So worst at the top, best at the bottom. Okay, so I'll just walk through them quickly. The first one, SciGet, gets an element, HTML element button. Could be any button. Just give me one. Give me the first one in Cypress, and click it. God damn it. Could be a cookie pop-up. Could be search. button next to a search field. Could be anything. I have no control of it. The second one is a CSS, it's a class selector, so I need any element. Could be a div, a span, could be the body, but it needs to have the classes button and primary. Just click it. Could be anything. The big drawback with this one is, just as you change from Angular to React to server-side rendered to, just as you change your underwear, this will change. So the CSS classes are there for styling. They're not there for your tests. Make sense? Yeah. So multiple interests in that kind of information is a bad thing. We need something which is just for the test, because when you change from Bootstrap to whatever, Tailwind, all the end-to-end test fails. End-to-end tests are bad. Out with them. All the developers writing end-to-end tests are stupid. Out with them. Don't do that. The third one is using an ID, so it could be any HTML element with that ID, and it's the same with CSS classes. Most of the time we use IDs for CSS. Sometimes we use it for application logic, but it's not for tests. It's not for your tests to use as a handle to get the correct element. It's for the application, or for the styling. And the fourth one, the name attribute, that's also for the application, same as the ID. Could mean anything in a form, for example, and it will change. And it will change in a context outside of the end-to-end tests. Okay, moving down to the good stuff. The first one is contains. This will just find the text on the page and click it. So this could be a heading, or it could be a button. If it's a heading, we'll get some kind of error saying that it's not clickable. If it's a button, it's clickable. It has a click listener. Cool. It's okay, but if you change like the phrasing here, things will fail. It's kind of sad, but it's kind of good, because sometimes phrasing is important. Yes, question? No. So if you run this in a CI environment in Poland, and you have Polish translations, everything is red. Out with the developers writing end-to-end tests. Out with them. I don't know what they do in Poland. And the last one, use a specific data attribute for your tests. It's a good thing, because you can use this attribute in low-level component testing as well. So if this is like, say, a React component with a button in it, you can use that for unit testing that components as well. Use something specific for your tests, something that's not bound to be changed when you change framework, etc. Okay? So here's the warning label stuck on this presentation. End-to-end tests does not substitute unit tests. It's not an excuse for you to not write unit tests or checks. It's not an excuse for you to not have human testers, exploratory testers, but it can prevent a lot of regression sneaking into your application over time. And of course, remember the pyramid. End-to-end tests were a small part of the pyramid. The amount of end-to-end tests should be a small part of your test suite as well. One of the application, yes? Yeah, the question, how long is a string, right? How long is a rope? So how many end-to-end tests should I have? I work in a code base right now where we have roughly 6,000 unit tests, and we have 7 end-to-end tests. Try to keep one for each major feature or use the story of this application. No overlapping, just single happy runs through the application. There's no silver bullet. End-to-end test is not a silver bullet. I'm not trying to sell you guys snake oil or something. This will not solve all your problems, but it will take some of the problems away. And this is just one layer of the testing pyramid. So don't forget about the others. Don't try to flip the pyramid upside down or anything stupid like that. Right. So, to summarize this, I'm not sure how much time I have left. You know? No time left? Sorry. So guys, write these tests from your user perspective, please. Write them first. We had no issues doing that, right? We saw the test, we knew nothing about the application, we could just write these kind of tests first and run them. Make sure you use domain language and don't repeat yourself. So if you're using these CSS selectors in a lot of tests, which I show you, try to wrap that in a function. Do something smart, which is readable to a human being instead, and use that in your tests. And please write these tests together with the domain experts. Use, was it a QI, QA, kickoff? Do that and write these tests. They will act as a spec, they will act as a proof of that you're done. So write them first and do it together. I hope I've given you guys a couple of tips which you can take with you, and hopefully you will try to write some new end-to-end tests without the pain. I have been using this for about 5 years, and I'm still not feeling the pain during these 5 years. Thank you very much.